In this video, we're dealing with a definite integral. Here it is, the definite integral from 0 to pi over 2 of cosine x over 1 plus sine x dx. So just like before in the previous problems, we want to look for some type of substitution approach. So for lack of anything better, if that had, by the way, been 1 plus sine over cosine, then we could have divided cosine into both top and bottom, and we'd have had something we could have worked on and done the integral of. But because we have the double term in the bottom, that's why it doesn't work. We can't just divide into the top and bottom now. But here we can try substitution. Let u be the bottom, 1 plus sine x. We then do the derivative and get that du is cosine x dx. Okay, so I have du exactly as I needed. I don't have to change it. And I have u, so I can rewrite it as 1 over u du. Now you have two options here as far as the limits of integration go. We could go ahead and change these so that everything's now in terms of u, and then we wouldn't need to change back. I usually just, a lot of times, will just not write anything down for u here, but I did want to change them to u because it is incorrect to write 0 to pi over 2 here now that we've changed the variable over to u. So I just write u equals blank and kind of leave them there, and then I'm going to convert back to x. But you could go into the function and say, well, what is u when x is 0? You could put that in. What is u when x is pi over 2? And then you could put those new limits in, do the integral in terms of u, and then you don't even have to turn it back in terms of x. You can just evaluate at those new endpoints. But I'm going to keep it like this. Integral of 1 over u is just natural log absolute value. And then I can replace u with what it is, which is 1 plus sine. So I get ln absolute value of 1 plus sine of x. And now I go back to my original limits, which involved x, which was 0 to pi over 2. So now we just go ahead and plug that in. ln absolute value of 1 plus sine of pi over 2 minus ln absolute value of 1 plus sine of 0. Well, sine of pi over 2 is 1, so 1 plus 1 would be 2. Absolute value of 2 is just going to be 2. And then here, sine of 0 is 0. 1 plus 0 is just 1. So we get ln of 2 minus ln of 1, but we remember that ln of 1 is 0. So then we have our result here, which is ln of 2. ln of 2. And then the last thing I want you to see here is that's the picture of our function there, cosine x plus sine x from 0 to pi over 2. So that's the little section there that has an area of ln of 2, which is approximately about 0.69. About 0.69. Okay, so there's an example of a log integral that actually was part of a definite integral, where we are looking, in this case, since this function was always above, it is actually the area beneath that curve.